and welcome back to Middle School Math with Dr. Koenig. Today we're focused on converting our fractions of all sorts, mixed numbers, improper fractions, and so on, to decimals. Let's get started. Before we actually convert one of our fraction examples to decimals, it's important to familiarize yourself with your decimal place values because that's really helpful in converting a fraction to a decimal, is knowing those place values. Now, you'll see here this handy dandy chart I have. That is not my creation, so credit goes to Math Kids in Chaos. Thanks for making something so useful and beautiful that I could pull from. This chart will help us to place things in the correct spaces and convert a fraction into a decimal. So, when you have a fraction, ideally you're looking for something that would naturally fit into these decimal places, the tenths, the hundredths, the thousandths. Here I have a fraction that says 7/10, which means that the 7 goes in the tenths spot. Now, we usually don't have just 0.7, we would make that 0.7, but because there's really nothing else to contend with, we've already converted that number. It is 0.7. The same would go for that second fraction. We have 75/10. What's different is that this would be like an improper fraction, or we could rewrite it as a mixed number. When that happens, we want the digit to end in the tenths place. So the second number is what goes in the tenths place. So I'll put my 5 here, which means my 7 has to go in front of it. They stay together. It just ends in the tenths place. So now you can see that this decimal equivalence is 7.5. Now, there are some fractions with denominators, of course, that are not 10 or 100 or 1,000, but could easily be manipulated to become those denominators. So I'm actually going to start with the one on the right, this one that has a denominator of 25, 51/25. If I multiply that fraction by 4 on the top and 4 on the bottom, it would become 204 over 100, which is 204 100ths. Again, I need this last digit to be in the decimal place that we're representing, the hundredths in this case. So I'll write it backwards. I'm going to start at my hundredths, and then I'm going to make sure it says 204 right in a row. And I can clearly see that my decimal is 2.04. Now, it works that way for any number. If I can get the denominator to be a 10 or 100 or 1,000, it's an easy decimal to write. For example, 1/4. If I multiply by 25, what I end up with is 25 over 100, which is 25 hundredths. So I'll need to write this into my decimal place value box. And remember that that second digit is the one that goes in the hundredths place. So the 5 goes here, the 2 goes here, and we'll add a 0 just for good measure. We always want something in front of that decimal place. So the decimal equivalence of 1/4 is 0.25. Now, this third example that I'm coming back to is written as a mixed number. I always suggest turning those into an improper fraction first and then converting. It's kind of like when we're multiplying or dividing fractions, we want them to be improper first. Very similar thing here. So I'll multiply 1 times 5 and add the 1, which all gives me 6. Remember, the denominator stays the same. Once I've written it as an improper fraction, I see that I can multiply by 2 and I'll end up with tenths in my denominator, which is one of my decimal place values. Once I have multiplied by 2, I can see that my fraction is 12/10. I'll make sure that my second digit is the one that goes in the tenths place, which tells me the decimal equivalence is 1.2. This example that you see before you, 5/8, is a little bit different because 8 doesn't naturally go into 100 nicely. Now, we can multiply it by 12.5 on the numerator and the denominator. However, this is an example where there is another method that might be helpful to get us to that 100. The reason why I would avoid multiplying by 12.5 is because it's a little tricky, easy to make some mistakes. So I want to show you on this one, and for any other example where the denominator doesn't go into 100 nicely, a method that will work, and it works all the time with any fraction. Whether or not it's easy to convert, this method still works, and that method is long division. So we can take the 5 and divide it by 8, and here's how that works. Now, in order to divide a smaller number by a bigger number, I always put a decimal and a few zeros because there's a lot of bringing down zeros so that you can keep going and finish the problem. Now, I know that 8 does not go into 5 at all, so I'm going to put a 0. And then immediately, first thing, I'm going to bring up this decimal so that it stays in the right place and I don't mix up my place values. Now, 8 times 0 is 0. I can subtract and I'll get 5, and I'll bring down a 0. 8 goes into 50 6 times, which is 48. Subtract and get 2. Bring down another 0. 8 goes into 20 2 times. That's 16. Subtract and get a 4. Bring down another 0. Now at this point, you're probably thinking, will this problem ever end? Yes, they usually do. Usually if you're working on this in class, you're looking for something that ends or clearly repeats. And we'll look at a repeating example shortly. 8 does go into 40 nicely, and that is 5. When I subtract, I get a 0, which is how I know that I'm done with this problem. I've used all of the digits at the top, and I've gotten a 0 remainder. That tells me that the decimal equivalence of 5/8 is 0.625. Now again, could I have multiplied by 12.5 and gotten 62.5 and then converted? Yes, but the long division is another method and it works on every fraction, which is what makes it a nice method to pull from. This last example is very similar to the previous example where 6 does not go into 100 nicely. In this case, there isn't really like a multiply by 12.5 something, a fact that you might know. You might know what your sixths are in decimal form, and that's okay too. However, the easiest route for conversion is to do long division. Now remember that the top number is what goes in the box and the bottom number is what goes outside of the box. And because I know 6 doesn't go into 11 nicely, I'm going to add some zeros. You can always add zeros after a decimal place at the very end of the number safely without changing the value. So 11.000 is the same value as 11. Now 6 does not go into 1, but it does go into 11 one time. Before I do anything else, I'm going to bring up my decimal place so that I don't lose my place value and mix anything up along the way. I'll go back to 6 times 1, which is 6. Subtract and I get 5, bring down a 0. 6 goes into 50 8 times, which is 48. Subtract and I get 2, bring down a 0. Make sure that you're bringing down a 0 at every step. That's why I use the arrows so that I can see every single time I bring down a 0. 6 goes into 23 times. 6 times 3 is 18. I subtract and get a 2. Bring down a 0. 6 goes into 23 times. 18. Subtract and get a 2. Bring down a 0. And I'm starting to have deja vu. I'm seeing that I've gotten 20 a few times. 3 times, in fact, which tells me that I am stuck in an infinite loop. That means that this is a repeating decimal. So 11 sixths is equal to 1.83333333 forever. And what we can do to show that with symbols is put a line over the 3. That's the thing that repeats, so that's the thing that gets the line over it. And there you have it. 11 sixths is equal to 1.83 with a 3 repeating. So that's converting fractions to decimals. That's kind of a summary of any example I could give you. The only thing I didn't throw into this video that I maybe could have was a negative, but it doesn't change the process. It just changes the result. You'll need a negative decimal if you had a negative fraction. So remember, if you can make the denominator into a number that is a place value like a 10, 100, or 1,000, do that. That's the easiest way to convert a fraction to a decimal. If you can't, a standard way that works for every single problem is to use long division. Remember that the top number goes in the box, the bottom number goes out of the box. So I hope this led you in the right direction for converting all of your fractions to decimals, which I know you're excited to do when you leave this video. Thanks so much for being here. I'll see you next time.